Every single day, we're all interacting with this incredibly powerful, totally invisible force that runs our entire digital lives. I mean, it's the unsung hero inside your phone, your laptop, even your car. But what is it, really? Okay, let's pull back the curtain and meet the invisible boss in your machine, the operating system.
Seriously? Think about it for a second. You click on an icon to open up an app. Seems simple, right? It feels instantaneous. But in that tiny fraction of a second, an unbelievable, complex chain of events is kicked off. So who or what is pulling all the strings behind the scenes?
Well, that's where we meet the main character of our story today, the computer's invisible boss. This is the manager that's working nonstop in the background, making sure that everything you want to do on your computer actually gets done. So what is this boss exactly? Well, the official definition says it's a program that acts as an interface, a bridge. It's the absolutely essential link that connects you, the user, with the physical nuts and bolts, the hardware of your computer. Honestly, without this bridge, your computer would just be a very expensive paperweight. The OS really has three main jobs on its plate. First, it's there to make using your computer easy and efficient. No confusing code, just clicks and taps. Second, it's the ultimate resource manager, controlling every single piece of the system. And third, it provides the fundamental stage where all your other apps, your games, your browser, you name it, can actually run.
Now, to really get why the OS is so critical, we've got to understand the fundamental problem that it solves. And you can think of it like a massive communication breakdown, a classic case of two parties being completely lost in translation.
This diagram here just lays it out perfectly. See, at the top you've got us, the users, and our apps. Way down at the bottom, that's the physical hardware, the CPU, the memory, all that stuff. And notice what's sitting smack dab in the middle? The operating system. It's the universal translator, connecting our world to the machine's world.
And this right here brilliantly illustrates that language gap. When you click an icon, the hardware has no idea what that is. It just understands electrical signals. You type a word, it only gets binary code, ones and zeros. You save a file. To the hardware, that's just a change in magnetic states. There's a huge, huge disconnect between what we do and what the machine actually understands.
So how in the world does the OS bridge this giant gap? Well, it actually plays two roles at once. It's not just a translator, it's also the conductor of a very, very complex orchestra. Right, so the OS is wearing two hats. First, it's the master translator. It takes our requests like, hey, open this file, and translates them into the binary language the hardware gets. Then it puts on its conductor hat and coordinates all the physical parts, the processor, the memory, the storage, to execute that command perfectly, all in sync. And this is so cool because it shows the abstract and the real side by side. On the left, you've got a simple block diagram of a computer's parts. But on the right, that's an actual motherboard. The OS is the boss of every single component you see there, from the CPU sitting in its socket to every single stick of RAM. It manages the whole shebang. And its to-do list is, well, it's huge. It's deciding which programs get to run and when. That's process management. It's juggling the computer's precious main memory. It handles every single signal from your keyboard and mouse, organizes all your files on the desk, and on top of all that, it keeps the entire system secure. It is a very, very busy boss. Okay, so let's get practical. How does the OS actually juggle all of these tasks at once? How can you possibly listen to music, browse the web, and type in a document all at the same time? Well, the secret is a constant, high-speed conversation that's happening inside the machine. The magic behind all that multitasking we take for granted comes down to one thing, something called interrupts. You can think of these as tiny, urgent messages that are constantly flying around inside your computer. The operating system is basically built to be interrupt-driven. It's always just waiting for something to happen. And the scale of this is just staggering. A high-performance server isn't just handling a few of these messages here and there. No, it can be processing hundreds of thousands of them every single second. That's the mind-boggling level of coordination the OS is managing.
So how does one of these interrupts actually work? Well, imagine the CPU is super busy, chugging away on some task. When you press a key, the keyboard hardware sends out an interrupt signal. The OS basically taps the CPU on the shoulder and says, hey, pause what you're doing for a millisecond, we need to show this letter on the screen. The OS handles it, and then the CPU goes right back to what it was doing without ever missing a beat. This happens for every click, every key press, every packet from the internet.
Okay, another one of the OS's huge jobs is managing storage. And as you can see here, not all storage is created equal. I mean, ideally, all our storage would be incredibly fast, but that would be insanely expensive. So instead, the OS manages a hierarchy, a pyramid of different storage types. At the very top, you have tiny bits of ultra-fast memory, and at the bottom, massive but much slower storage. The OS is constantly juggling data between all these levels, always trying to keep the most important stuff in the fastest place.
And just look at the difference here. I mean, wow. Accessing the fastest storage, the registers on the CPU, takes less than a nanosecond. Accessing your solid-state drive, which we think of as pretty fast, takes tens of thousands of nanoseconds. It is the OS's job to intelligently shuffle data around so that the stuff you need right now is always in the fastest possible place.
Okay, so we've seen the OS is a translator, a conductor, and a master manager. But why does any of this techie stuff actually matter to you in your day-to-day life? It matters because, as this quote from the source material makes super clear, everything you do runs on top of this system. Knowing how the foundation works isn't just for computer programmers. I mean, you ever wonder why your computer gets slow when you open way too many tabs? Yup, that's the OS struggling to manage memory. Understanding the invisible boss helps you understand your own technology so much better. So if you remember anything from all this, let's have it be these 3 points. First, the OS is the master resource manager. It's the one deciding who gets the memory, the processing time, the disk space. It's the whole reason multitasking is even possible. Second, it is the essential interface. Without it, your favorite app would have no way to talk to your screen or your keyboard. And finally, it's the invisible foundation. Just like the foundation of a house, you never see it, but everything you value is built right on top of it.
You know, from Windows and Mac OS to the Linux that basically powers the internet and all the mobile operating systems in our pockets, these invisible bosses truly shape our world. They are the silent foundation. Which, of course, leaves us with one last question to think about. What happens when that foundation begins to change?